Making process experiments is quite easy. All we need is a project that has some online control unit. We can build one, or we can open our test example. You can see that we have one control unit which is online, and on this online control unit we can do some process experiments. But first of all, what is process experiment? When I open control application diagram, I see my control unit, and inside this control unit I have my diagram. This diagram defines behavior of the real-time control unit. I have inputs, I have outputs, I have different processing functions. I can see that I have control functions connected between them. But structure is a little bit more complicated. The real structure of the control application diagram is shown here. Each control function has in fact a control variable if it has an output. So each output has its control variable. If the control function has a name VFSP, then the control variable has name VFSP out 0 or 1 or 2 or 3. It depends on the index of the output. So the real structure of a control application diagram is this one. Now, what is process experiment? Process experiment procedure is displayed here below. So process experiment is a procedure where I replace values of the computed control variables. So for example, here in this example I have decided that this control variable will not contain computed value of this PID controller, but some constant value. This is called constant override or forcing, or sometimes it's called manual, switching from auto to manual. It's typical for normal process control. What is not so typical is this one, dynamic override. Here I have decided that in this control variable I will use computed values, but I will add some excitation signal. This signal will serve us to discover the behavior of the process. So process experiment is, first of all, to define my constant overrides, my dynamic overrides. I can have several dynamic overrides as well as constant overrides, and then to define recorded signals. I have to decide which variables I want to record during my experiment. So this is how process experiment look like. Now I can go back to my project. I have my online controller. I will visualize my control variables, and I can start my process experiments. Process experiment tools. In basic tool, I have only two experimental tools. I have process experiment procedure, which does what I saw in the figure, and then Ziegler Nichols PID tuning. First I show what is it process experiment procedure, how it works. When I do not have an online controller, a real controller, I can do simulation. So I click simulation and I launch the tool. What the tool does, it's written here in his description. Process experiment will be executed according to specifications defined in the experiment specification window, and recorded signals will be just displayed. So in this window now I define what I have shown before. Constant overrides. I select variables and add to my list. On these variables I apply constant overrides. I select variables for dynamic override like this, and here I can select my recorded variables. Now I can start if I'm satisfied with these selections. For example, for constant override, I have to define duration of the constant override, start delay, the value of the constant override, obviously. In dynamic override, I define just the delay, start delay, and the signal that will be sent into my process control. And here I define just the signal where will be stored my recorded signal. I have these two same variables. I should change one. So for example, here I change the variable of the signal will I have my excitation signal samples. Now I start a real-time process experiment. When I do simulation, when I click this checkbox, I have this window. Process experiment simulation requires that you provide recorded signals for the following control variables. This is this variable which I decided to record. In simulation, I have to give the recorded signal. Each signal must be stored in a global structure variable containing fields, times, and values. If I click yes, I have this answer: no recorded signals obtained from experiment, because I didn't define this signal which should be the result of the experiment. So I define it here in the workspace. First I have to define the variable global. Then I can define a vector that will serve me for samples. Now I can define the field values. I place here the defined samples, and I have to define the field times. Here I can put values from 1 to length of my values. Okay, I have my result of my experiment, and I can restart my process experiment simulation. Proceed with experiment. Yes, that's all. I've just displayed my simulated signal. If I did not click simulation, the tool will try to connect to process to my real-time control unit and do the real experiment. So this is first tool. It's just a process experiment procedure. The second tool here is Ziegler Nichols PID tuning. For PID tuning, I have to select a PID controller. If I did not do that and I launch the tool, I have here the error. Select PID controller first. So we have to display control functions first and find the PID which we want to tune. For example, this one. Now I launch the tool. Here's the description of the tool. Proceed. Yes. Okay, this tool asks me only two things: the step, amplitude of the step that will be applied to the process, and estimated process response time. Next, because I'm in simulation, next the tool asks me that if he can apply the step. Okay, we can do it. And because we are in simulation, the tool asks us give us the actual value of the PID output, because the tool needs for some reason actual value of the PID output. I'll click OK, and because I'm in experiment simulation, I have again this window that says process experiment simulation requires that you provide recorded signals for the following control variables, and signals must be in these variables. again in the structured way stored. If I click yes, experiment failed because these variables are not yet defined in my workspace. So I have to first define them. I don't need to do it by hand for this Ziegler Nichols PID tuning method, because in the tool we have example of these signals in this file. So these two variables will be defined global. Here I have response, here I have step, time, and here's the definition of the structure. All I need is to call this file, and I have these variables defined in my workspace. Now I can restart my Ziegler Nichols tuning in simulation. Here I choose the proposed values 10 and 10. Do you want to apply steps? Yes. Actual value should be set to 7 according to these signals, so I choose 7. Okay. Yes, my signals are now ready, and I have the result of PID tuning. I have values for P controller, PI controller, as well as PID controller. I see here the response. I see also estimated tangent. On this window I see applied steps and process response.